Food Metabolome Repository contains metabolome data obtained by LC-MS and from 222 foods. Liquid chromatography, mass spectrometry, is one of the major apparatus used in metabolomics. The compounds are first separated by LC and then ionized, and the mass values of the ions are measured by MS. This is an example of LC-MS data. X-axis shows the retention time of LC, and hydrophobic compounds are eluted later time in this condition. Y-axis shows the mass-to-charge ratio, which corresponds to molecular weight, and the red dots are the compounds. Hydrophilic compounds such as amino acids are eluted earlier, lipids are eluted later, and the many secondary metabolites derived from plants such as flavonoids are eluted at the middle of the chromatogram. Please ignore the peaks always eluted in all retention time range. These are the contaminants in the solvent. And also ignore this vertical line around 70 minutes. And this is from the internal standards. Using this two-dimensional mass chromatogram, I'll show you a diversity of metabolic profiling among food samples. Vegetables have large variety of chemical profiles. This is cabbage, soybean, cucumber, parsley, perisia, and ginger. Especially in the medicinal plants such as ginger contain a large number of metabolites peaks like this. In contrast, there is a food category that contains a small number of peaks. That is fishes. This is sardine, alfonsino, tuna. They contain almost only the lipids. Bonito shows the similar profile like this. But interestingly, when the bonito is processed to make soup stock, its constituent becomes very complex like this. This is also observed in the mushroom soup stock. This is profile of raw mushroom, and this is soup stock made of shiitake mushroom, very, very complex. Such a complex composition of compound is also observed in the processed food such as beer. But in the case of alcohol-free beer, almost nothing. As shown here, there is a very big diversity of compounds profiles among the things around us. For your information, all these slides can be downloaded at the top page of the Food Metabolome Repository website, so please compare the profiles by yourself, if you like. Okay, one of the biggest issues in metabolomics is that there are many unknown compounds. In the case of foods that contains 4,300 peaks in average, more than 70% are unknowns. This is the same for other samples such as human plasma. In this case, only 21% of the peaks found candidates that match their mass values to those in the existing compound database. This is a big issue for us, but also this is a very big chance to discover novel new compounds.